In this video, we're going to talk about parametric curve or parametric equations. If x and y are given as functions as x equals f of t, y equals g of t, meaning that x is written in terms of t and y is written in terms of t, over an interval of t values, then the set of points x, y equals to f of t, comma, g of t, defined by these equations, is a parametric curve. The equations are parametric equations for the curve. And let's look at some examples. So let's say you got x equals radical t and y is equal to t when t is greater than or equal to 0. So when you make a table, I made a table by creating t, x, and y. And when t is equal to 0, when you plug in the t values to x and y, you're going to get 0 and 0. And when t is equal to 1, you get x equals 1 and y equals 1, and so forth. Notice, you could go on and on and on, but these are the values. Now, notice, the advantage of parametric equation over rectangular is you can locate the rectangular respect to time in parametric. So example, you could say that when t equals 0, where is the particle? When t equals 1, where is the particle? That's why parametric is sometimes more useful than rectangular coordinates. So in order to graph parametric, what you need to do now is press mode, and instead of function, you need to go to parametric. Press enter, and then go to y equals. Now you could write x as radical t and your y1 as t, and go to window, and we got a t minimum is 0 because t has to be greater than or equal to 0, and then t max, let's just set it as maybe 100 because t is going to infinity. Yeah, because t has to be greater than or equal to 0. And when you graph this, look at that. You get a half of a parabola. It makes sense because, think about it, x is equal to radical t, right? So when you square both sides, you're going to get t equals x squared. Now let's use substitution. Instead of t, let's plug in x squared. You get y equals x squared. And this is a parabola. But notice we had the restriction. That's why it was only a half of a parabola. So you could change parametric to rectangular easily by using substitution method. By the way, it should be y equals x squared when x is greater than or equal to 0. We have to put that restriction here because that's a half of a parabola. And also there was a direction. When you graphed it, you went towards this way. So make sure you draw the arrow of the direction. Now let's see what happens when we graph x equals 2 cosine t, y equals 2 sine t from 0 to 2 pi. So I'm going to put my x1 as 2 cosine t, y1 as 2 sine t. Remember, when you press this button now, you will get t. And let's go to window. T is going from 0 to 2 pi. And let's graph and see what happens. The graph looks like an ellipse, but let's make it better. Let's go to zoom, fit. So let's press 0, zoom fit. And then you get this graph. Actually, this looks like a circle. So let's go to zoom and put square 5. So it is a circle with a radius of 2. Now notice this one graphed really fast, but on your calculator, you'll notice that it went this way. So that is the direction of this parametric equation. It went counterclockwise. You should definitely try it with your graphing calculator as well. I am doing this on computer, so it graphed really fast, so it was hard to see, but it went counterclockwise. And it is a circle with the radius 2. So this is how the graph should look like with the direction. And let's see why this became a circle. Let's solve for, now let's go back to trig. You know that cosine squared t plus sine squared t is going to be 1 from trig. So using x equals 2 cosine t, you know that x over 2 will be equal to cosine t, and sine t will be y over 2. So when you square both sides, you're going to get x squared over 4 equals cosine squared t, and you get y squared over 4 equals sine squared t. So using substitution, we're going to get x squared over 4 plus y squared over 4 equals 1. Now I'm going to multiply everything by 4. You're going to get x squared plus y squared equals 4. Now remember, this is a equation of a circle with the center 0, 0. And because the equation of a circle looks like this, x squared plus y squared equals r squared with the center 0, 0. So r is 2. That's why we got this equation, the graph of a circle with the radius of 2, the direction going counterclockwise. Now let's graph this parametric equation and see what happens. You want to graph x equals 3 cosine t and y equals 4 sine t, and let's go to window. T is going from 0 to 2 pi. So let's graph it. Let's go to zoom, standard first, 6. So as you can see, the graph went counterclockwise again. It did so fast, it was hard to see it, but make sure you use your own calculator. It went counterclockwise. Is this a circle? Well, it looks like it's not, because you got 1, 2, 3 over here, and you got 1, 2, 3, 4. So it looks like this is an ellipse. So to get a better view, let's go to zoom, and let's go to zoom fit 0, and go to zoom square. Yeah, so as you can see, this is an ellipse going this way, counterclockwise. So this is how the ellipse will look like with that direction going counterclockwise. Now notice, when t equals 0, right? When t equals 0, let's plug in 0. What do you get? What's cosine of 0? 1. And 1 times 3 is 3. So that's, when t equals 0, x equals 3. And when t equals 0, sine of 0 is 0. So 0 times 4 is 0. So y is equal to 0. So when t equals 0, the location is at 3, 0. What about when t is equal to pi over 2? What is cosine of pi over 2? That's 0. That's 0. 0 times 3 is 0. And sine of pi over 2 is 1. 1 times 4 is 4. So when t is equal to pi over 2, x is 0 and y is 4. That's why the particle will be over here. So that's why the direction goes like that. Now let's see why this became ellipse. So let's solve for cosine t. You're going to get x over 3 is cosine t. And when you solve for sine t, you get y over 4 equals sine t. Now again, you know that cosine squared t plus sine squared t is equal to 1. So using our substitution, square both sides, you're going to get cosine squared t equals x squared over 9. Plus, when you square both sides, you're going to get sine squared t equals y squared over 16 equals 1. Now, if they both had the same denominator, you can multiply all of them by that denominator and you'll get a circle. But unfortunately, 9 and 16 are different. That's why we got an ellipse. Now notice, the y direction, what's the number below y squared? It's 16, right? What's the square root of 16? It's 4. That's why from the center, 0, you went up 4 and you went down 4. What about the number below x squared? It's 9. The square root of 9 is 3. So you went 3 to the right and 3 to the left. So when you change the parametric to rectangular, this is what you will get. Now let's see what happens when we graph x equals 3t and y equals 2 minus 2t from t going from 0 to 1. So we got x equals 3t and y equals 2 minus 2t. And let's go to window. And we're going from 0 to 1. So make sure your window, when you go to your window, your t is going from 0 to 1. So when you graph that, you get a line segment. Now, again, use your calculator, you will notice that it's going this way. It looks like you're starting from 0 to 2, and then you end up at 3, 0. So this is how the graph looks like, going this way. That's the direction of this parametric equation. Now notice, when t equals 0, you get 0, 2. That's the starting point, isn't it? And when t equals 1, you're going to get 3, 0. That's the end point. That's why the graph looks like that. Now, let's try to change this to rectangular. So we know that x equals 3t. Let's solve for t here. T is going to be x over 3. Divide both sides by 3. And then instead of this t, we're going to substitute x over 3. So y equals 2 minus 2 over 3 times x. So this is the same thing as y equals negative 2 over 3 times x plus 2. So the y-intercept is 2, and the slope is negative 2 over 3. So this is a line segment. But there is a restriction, isn't it? It only goes from 0 to 2 and 3, 0. So this was an introduction of parametric equations. In our next video, we're going to find derivatives and antiderivatives.